Welcome to the 6th episode of JWST and the Big Bang Never Happened debate. In this episode, I'd like to reply to some cosmologists who said, well, sure, we know there are some problems with the Big Bang theory, but all that's needed is a little tweaking.
But a disagreement can point to the need to tweak an existing theory.
So yes, our models are going to need some tweaking in order for us to get disk galaxies forming much earlier in the universe.
Well, that's really not true, because the truth is that in published papers in the literature, nearly all the quantitative predictions of the Big Bang hypothesis have been contradicted by observation. And this is well known in the field. In fact, papers have been written by hundreds of authors that have pointed out many of these contradictions. And people are really concerned about this. In fact, we've obtained an audio file from an anonymous astrophysicist who expresses her concerns from the standpoint of a Big Bang supporter. Now, we've disguised her voice a bit and added a few images to illustrate what she's saying. But before we go on, let's listen to this file.
Tiny bright images, too little helium, lopsided star maps, too little lithium, vast swarms of matter that stretch out in strings. These are a few of the craziest things. Far distant galaxies revealed as too small. Big Bang theorists say they're not there at all. A much older past with so much too big things. These are a few of the craziest things. Plasma cosmologists out of the past. A growing universe that's far too fast. Microwave patterns laid out in straight lines. These are the things that aren't looking so fine. When it's good night, things are alright. When I'm feeling bad, then I remember the craziest things, and then I just feel so bad.
So, since she expressed herself so concisely and so poetically, let me explain point by point what are the things that concern her, the contradictions between observations and the Big Bang hypothesis. I'm going to be concise because in almost all cases, we've already dealt with these issues in depth in other videos. And in the description, we'll refer you to those videos. In all cases, we'll also show in the description the technical peer-reviewed papers that illustrate or demonstrate the actual contradictions between Big Bang hypotheses and the observations. So when she says tiny bright images, far distant galaxies revealed as too small, well, here she's talking about what's probably the worst news for the Big Bang theory from the JWST, which is the contradiction of what's called the Talman test. So the Talman test involves this well-known optical illusion that must occur if the universe is expanding, which makes objects appear larger in the sky when they become more distant, unlike in ordinary space where things that are more distant look smaller on the sky. And of course, what the JWST revealed, as the Hubble Space Telescope had revealed at smaller distances, is that the galaxy images do indeed get much smaller at greater distances, at greater redshift. And they're very bright. And this completely contradicts the basic predictions of the Big Bang hypothesis. And we've discussed that at length in earlier videos in which we showed that the sizes of the galaxies with the Big Bang assumption become impossibly small. And it's not just that they're implausible, they're impossible, because there are independent measurements that can be made from independent data that show that these galaxies cannot be as small as predicted with the Big Bang assumptions, that if they were regular sized, they'd be much larger in the sky. So these images are a real theory killer, and that's why this astrophysicist and many others are very upset. And they're so upset they just won't discuss this basic contradiction. In fact, they keep saying, oh, it's just that the galaxies are too old, maybe they evolved faster. We'll get to that in a second. Now, when she says too little helium, well, again, she's discussing a very basic prediction of the Big Bang theory, which is that there should be a certain amount of helium produced by fusion reactions during the Big Bang. And there should be more helium in stars that have processed hydrogen, but there should be no less helium than this prediction. But observations have shown that in nearby stars and even in planetary nebula, these bubbles of gases around stars where we can observe helium directly, the amount of helium is only half what's predicted by the Big Bang. Another fundamental contradiction, which is explained if we assume the helium is just produced by stars in the early life of each individual galaxy, and there was no Big Bang. Lopsided star maps, well, what's worrying her and other Big Bang cosmologists is that the very basic assumption of the Big Bang theory is that the universe is homogeneous and isotropic. Homogeneous means the same everywhere, isotropic means the same in every direction. Without those basic assumptions, there would be no expanding universe, there would be no Big Bang. General relativity only predicts an expanding or contracting universe if the universe is homogeneous and isotropic, which has never been observed. And today, with even better observations, there are more and more anisotropies. When we look in different directions in the sky, we get different measurements. We get different measurements, for example, of the Hubble constant, the constant that describes the relationship between redshift and distance. We get different densities of radio galaxies, of X-ray galaxies, of quasars. All of these are different in different directions, and all of these produce these lopsided star maps, and therefore, again, contradict the basic hypotheses of the Big Bang. Too little lithium. Well, this again is the well-known lithium problem. The Big Bang makes predictions about 3 light elements, the abundance of 3 light elements: helium, lithium, and deuterium, which is the heavy isotope of ordinary hydrogen. Well, lithium, it gets wrong entirely. And as this graph shows, the observations of lithium are 20 times less than the predictions of the Big Bang. A gross contradiction, which again is explained if the lithium is created by processes that go on in stars, cosmic rays, processes that occur at the present time in our own Milky Way galaxy, not produced by some hypothetical Big Bang. Now, when she talks about Big Bang theorists saying that galaxies shouldn't be there at all, well, the JWST has revealed galaxies that seem to be older than the Big Bang, and therefore they shouldn't exist at all. It's possible, as we explained in the last episode, to measure the age of stars in a galaxy by looking at their colors, their spectra. And what you get is a contradiction, that galaxies that supposedly exist only 600 million years after the Big Bang contain stars that are 2 billion years old. Great contradiction. Adam Frank, well-known astrophysicist, says this is like looking for a nursery and finding people who should be in an old age home. Well, doesn't that make you think maybe you've gone to the wrong address? And in this case, doesn't that think maybe if you think that these galaxies should be very young and they turn out to be middle-aged or older, your theory is wrong. Now, when she talks about so much too big things, there's again a well-known problem in recent observations. If the Big Bang occurred, then we expect that only objects of a certain size should have had time to grow from this primordial plasma. But we see much larger objects like the Great Arc, objects that are billions of light years across and simply wouldn't have had time to grow in the time since the Big Bang. They would have taken tens or hundreds of times longer to grow to these enormous sizes. We figure when she complains about plasma cosmologists out of the past, probably she's talking about me, since I wrote this book, The Big Bang Never Happened, back in '91. So that's probably who she's referring to. A growing universe that's far too fast. Well, this is probably the best known problem with the Big Bang hypothesis. According to the Big Bang hypothesis, you should be able to actually predict the value of the Hubble constant, which again is the ratio of the distance to an object and its redshift, by observing the fluctuations in the cosmic microwave background, which has been done very carefully to very high precision by a number of satellites like the Planck satellite, WMAP. Now, of course, it's possible to directly observe what the Hubble constant is, because there are many independent ways of measuring distances to galaxies, independent of the redshift, and you can compare those actual measured distances, for example, to supernova, with the redshift that we observe. And then you can observe the Hubble constant. Well, as the predictions got more precise and as the measurements got more precise, they diverged. And they're still diverging. And this is far too great a divergence to be explained by errors in the measurements. And this is what even cosmologists have referred to as a crisis in cosmology. It's a flat contradiction. Of course, if there was no Big Bang, then the Hubble constant does not result from the expansion of the universe, but from some process that happens to light as it travels. And therefore, you can't predict the value of the Hubble constant from the fluctuations in the cosmic microwave background, and this contradiction disappears. Finally, she refers to microwave patterns laid out in straight lines. Well, another well-known problem, according to the Big Bang theory, the small fluctuations that we see in the brightness of the microwave background in different directions in the sky should be totally random. But as is clear from this map and from many other maps, On the large scales, they don't look anything like random. And you can do mathematical tests and show that they are not random, they are aligned and must be created by some non-random, some well-ordered process. Again, this totally contradicts the theory. This implies the cosmic microwave background doesn't originate from the Big Bang at all. And again, in published papers, I and other colleagues have shown how the microwave background could originate in the present-day universe by the thermalization and scattering of the energy produced by ordinary stars. Well, these are the problems that this anonymous cosmologist brought up, but it's certainly not a complete list. Maybe some of the other ones didn't quite fit the meter. So just to list these, we don't have time to discuss all of them. There's the problem of the matter-antimatter asymmetry. If there was a Big Bang, matter and antimatter would come into existence at high density and would annihilate each other. So there would be nothing left, no universe. It's a big contradiction. That's not what we see. So either there never was a hot, dense period where matter and antimatter could annihilate each other. In other words, the Big Bang never happened. Or there must be some asymmetry between matter and antimatter, so more matter was created than antimatter. But in billions of experiments that were done in the giant supercolliders, nobody has ever been able to see this asymmetry between matter and antimatter. In particular, the particle theorists said that if this asymmetry existed, protons should decay. Protons are the stable nucleons within every nucleus. And they've done experiments to see whether in large collections of matter that protons are seen to decay. Well, they're not. These very expensive experiments are all negative. Protons do not decay. And again, that's a complete contradiction of the idea that matter and antimatter are antisymmetric and that somehow a Big Bang could produce a universe that's nearly all matter. Clear contradiction with experiment. And again, this is not a complete list. There are so many contradictions with the whole essential notion of dark matter. The Big Bang theory requires dark matter in order to produce the universe that we observe. Dark matter is matter that's not like any matter that we've observed in the laboratory, but has mass. Well, they've been searching for dark matter for decades, and they haven't found any, with more and more expensive experiments. And this is one field where you can get lots of money, even though you have a record of complete failure. But that still justifies, well, we need a bigger experiment to look for the dark matter. Again, clear contradictions, and there are many astrophysical phenomena, such as interacting galaxies, where dark matter could not exist for these interacting galaxies to remain in a stable condition for many hundreds of millions of years. Again, all of these contradictions have been laid out in detail in the literature. Now, as you probably guessed by now, this anonymous cosmologist is also a fictional cosmologist. We developed the lyrics based on this list of contradictions. But the contradictions are nonetheless quite real. And there are not any predictions, except one, that are on the other side of the ledger. Only the deuterium prediction of the Big Bang is a correct prediction that is supported by the evidence. So on the one hand, you have 16 or more wrong predictions, and the other one right prediction. And as I've said previously, if an airline advertises that out of the last 17 flights, 16 crashed and one got through, would you fly on that airline? I think the answer is obvious. And the answer to the question, is the Big Bang a well-supported theory, is also obvious. With 16 wrong answers and one right answer, this isn't a theory that needs to be tweaked. This is a theory that needs to be thrown away. Now, not many people so far are willing to throw away the Big Bang theory. And again, we've explained the social pressures against doing so, which has nothing to do with the scientific evidence. On the other hand, there are a large number of people who are abandoning the current version of the Big Bang theory, which is called lambda CDM. Lambda standing for dark energy, CDM standing for cold dark matter. So this is the dark energy, dark matter inflation theory, which probably you've heard quite a bit about in the general media. And lots of people are saying, well, that version of the theory is wrong. And in the giant paper that we refer to in the description, authored by 200 cosmologists, they are backing away from the LCDM theory. But to what? The fact of the matter is, if you abandon this dark matter, dark energy theory, but maintain the Big Bang, you're basically retreating over a cliff, because the alternative becomes new versions, more complicated versions of dark energy and dark matter. And there's two big problems with that. One is there's essentially an infinite number of equations that you can invent to describe dark energy and dark matter. So the predictive power of the theory goes away. Because if you can predict anything, you're predicting nothing. And science is about predictive theories. That's why it's useful to us, as I'll discuss in a future episode. The second problem is many of the contradictions between the Big Bang hypothesis and observation, such as the tiny bright images, the Talman test contradiction, are not affected by whatever modifications you make to the theory. They're baked into the theory. This is the same that's true of helium, lithium. You can't change these predictions in any way to produce a concordance with observation. So there really is no intermediate position. Either the universe is expanding, either there was a Big Bang or there wasn't. And I think, I'm hoping, in the coming year or so, more and more astrophysicists who have taken this intermediate position will come to the conclusion, as we have and my colleagues have, that the Big Bang never happened. Thanks for watching, and we'll look forward to seeing you in the future. This research is entirely funded by the public through our crowdfunding efforts. The knowledge of plasma we gain from studying the universe is directly helping to harness fusion energy here on Earth in this decade. Help fund clean, cheap, safe, and unlimited energy, and get new knowledge of the cosmos at the same time. Find out how in the description. Fusion needs you.